Greetings. The topic of this video lecture is about mathematical concept of compound interest. Now, loosely speaking, roughly speaking, compound interest is a series of accumulation of simple interest. The name says it all, compound interest. Now, in order to fully comprehend the concept of compound interest, we must know way in advance about the concept of simple interest. Now, simple interest is an interest earned on a fixed amount of money with respect to the rate of the interest and the duration of time. Now, the rate of interest almost all the time, unless otherwise has been specified, is on yearly basis, annually basis. So whatever you hear in the bank or mortgage or finance or something that interest is involved, and they say interest is 5%, 2%, 3%, whatever, always it means at yearly basis. So anything that is related with the interest as far as duration of time is concerned, affiliated to interest, must be converted to yearly basis. Now what I mean by that, for instance, you don't say 1 month, 2 months, 3 months when you want, especially in calculation. We will go through some examples. You must say, for example, instead of 1 month is 1/12 of a year, or 1 week is 1/52nd of a year. So the duration goes on yearly basis. Now let's shed some light on the subject through some simple examples that I don't have to put it in writing, just orally I mention it. Then I have other things that I have written for you, and I'm going to go out of your way, zoom it. I don't have somebody behind the camera to do zoom in and out for me. I will do it myself mechanically, and then I go over those that they need to be written, and you may take a note. I'm afraid I don't have a chalkboard and board so that I could put it in writing. I've already put them in writing, I just hang them on the bulletin board. Now, suppose that you open an account in a bank, you deposit an account with $1,000, and the bank is giving you interest based on simple interest, which is principal times rate times time, all right? Now, the rate of the interest, let's say, is 10%. Again, it's annually. So at the end of the first year, you will be getting $100 interest. So how much you have in your account right now? 1,000 plus 100. At the end of the second year, again you are getting 100. At the end of the third year, again you are getting 100. Let's go for 10 years. At the end of the 10th year, you will be having $1,000 interest you have gained from the bank. So you have $2,000 in your account, but bank is still giving you 100 a year. It's very similar as an analogy like collecting rent. Your apartment or whatever you're renting remains same. It may also gain value, but remains same, and every year, at the end of the year, you go and collect rent from that $100, let's say. Now, since it is simple interest, you may say, okay, $100 divided by 12, that will be interest that I'm getting monthly. But depends on the agreement that you have made with the bank. If the bank says interest is on yearly basis and not monthly, I'm not going to pay you on monthly basis. So if you don't complete the whole year, you're not going to get any interest. And that goes especially for the compound when we go to that. The period must be completed. All right, now, two ways, in a sense. I have another one I'm going to put for you on the board, on the bulletin board, go out of your way. But before I do that, let me say one other thing, is that two ways you can outsmart the bank. One way is that at the end of each year, you take your interest out of account. So your account, the $1,000 remains there, so you go and collect rent in a sense. Take that $100 out. Do that the second year, do that the third year, and so on and so forth. The better way to do that is to compound it. Let the money stay, and then we are going to go through that and see how that one works. That we call it compound interest. All right. Now, I have an example for you. Let me first go through this one. I'm going to zoom it for you. You can write it because it's for students, especially at the basic algebra level. I'm present in the lecture. So you can write it, then I'm going to be out of your way and put some information on the bulletin board. Okay, here what I just said, you can put it in writing if you like to write it. Interest is principal times rate times time. And then I like this form of it better, if I may. Now here I wrote 1 over n instead of t, and that is the number of, for example, if this t is 12, then you are talking about 1/12 of a year, because it should go by the yearly basis. Then you know that you are collecting, it is a simple interest, but you are collecting your rent, in a sense, your interest on monthly basis, if I write it in this form. Okay, then this is just for, we are going to go, in fact, after that, when we go to compound interest. We will see it more often. Now, I have another example. Let me also zoom this one for you so that it's more visible. Okay, here I'm talking about simple interest, and I have put it in a chart, as you can see. That is beginning, that is the interest, how much interest you earn, and that is the ending balance in your account. Now, you all started with 1,000. You see 1,000, 1,000, 1,000, 1,000, that's the beginning, principal. Now, the interest rate, in this example, I put it 2%. So at the end of the year, based on year, you are going to get $20 interest. Do you follow? That's what I put 1 over n. If it is monthly, you can agree with that. If you say, okay, I want my interest to be on monthly basis. So at the end of the first year, you get $20. So you have in your account, the ending balance in your account is 1,020. Now, then at the end of the second year, again you are getting $20. Even though you have in your account 1,020, more than what you started with, still you are getting that $20 fixed amount like a rent. The same goes with the third and fourth and fifth year, and so on and so forth. Do you follow me? Okay, now let's see how we can outsmart the bank that I already mentioned, and see how we can come to the subject of compound. And what does compound mean? So let me put this one here. Now here, I'm on top of your way. Again, I'm depositing $1,000. The rate of interest is 2%. Again, yearly basis. I didn't have to mention it when I said 2%. Is always, you take it for granted, it's on yearly basis. No, that is first year, second year, third year, and so on and so forth. So you started $1,000 first, is that right? No, as I said, the second better one to outsmart the bank is what you do at the end of each year, close your account. And immediately after you close your account, open again. Now, how much you have in your account? You have, in this case, 1,020. So the bank has to pay 2% based on this 1,020. and 20 to your interest. Do you follow me? No, the Mac does that automatically. The computer does that automatically, but that is exactly what happens. At the end of the year, at the end of the period that is over, immediately your money becomes the first principal, become principal again. So it looks like you have a new principal, new principal, new principal, and so on and so forth. And that is exactly what the subject of compound interest is all about. That's exactly what it means. Now what we are going to do now, we are going to generalize this idea and come up with nice looking mathematical formula, algebraic formula for that by generalization. So we go from a specific to general in a sense. Okay, now so far so good. Now let me go to that was 6. Yes. Now before I go to that, I have something important to show before we go and see where the formula comes from. Sorry that my equipment are very primitive. I don't have access to a classroom. Now let me zoom this one for you. Again, I want to stay out of your way. Now, this is interest is principal times rate times time. This is the mother of all of them. All right. Now look what happens here. The one that I wrote in red, I hope that you are visible for you to read. Here, most of the basic algebra textbook, we see the amount, the final amount written in this way. But when you go to college algebra, usually you see this formula, and also this formula. So we are going to go through and see where each of them come from and what is the difference between them. And when can we use them? What is the benefit of one over the other one? Now we start from this one, if I may. Now here, this is the formula. We want to know where it comes from, huh? Basic algebra. Now here, at the end of the first year, look at what happens. Amount is principal times rate times time. But you don't see time here. Do you notice that? It's not there doesn't mean it's 0. As a matter of fact, it is not named because in the form of product is 1. Because we are dealing with what? Each year, the period is 1 year. So they don't write it, so don't get confused. Now look at this, what happens. The subject is, I'm going to go through that shortly, but is distributive law of multiplication over addition. Principal times 1 is P times 1 is P times R is P times R times T. T is 1, so look at that. Principal plus the interest. So if you started with $1,000, then $1,000 times 1.1 is equal to 1,100. 1.1 is same as 1 plus what? 0.1. Is that right? 1.1 is 1 plus 0.1. And 0.1 is what? 10%. 1 over 10. So it's 1,000 times 1 plus what? 10%, which is 1 over 10. So that ends up to be 1,100. Now, then this one becomes your what? Your new principal. You remember, you close the account and open it again. Now this is your principal. So principal, when you multiply by 1, that is principal, is itself. When you multiply this one by R and T is 1, don't forget, is principal. Then principal times rate times time, which is this one algebraic, but simplification. You know, A times A is A squared. You see that? Both of them is 1 plus R, so it becomes 1 plus R squared. So this is the second one. And this very same goes for the third. Now this becomes your what? This becomes your principal in a sense. New principal, you have your account, and you are going to get what? You are going to get percent of that, in this case 10%. So I have written all of them, you can write a note for that. So we know where the first formula comes from. Now, Let's investigate. So we are with this one. We already know this one. We came with that. Now let's see where this one come from. And these two are the algebraically equivalent. Not, I couldn't say equivalent. They're algebraically identical. But this has a better conceptual understanding about the subject. So I rather use this one, especially for the beginners, because the conceptual understanding concept, it is better explaining and conceptually understanding the subject. So let's go to the second one now, if I may. The second one is more interesting. Now we want to translate that previous example into what? Into algebraic, equivalent algebraic formula, algebraic symbols in a sense. Now, what I wrote here is students, basic algebra, they are familiar, distributive law, multiplication over addition, which I wrote for you here. Now here, since interest is principal times rate times time, and principal plus interest is what you get at the end of the each period, in this case at the end of the first year. So look what happens. I have, this is my principal, is that right? Then principal times rate times time. This is your time, 1 over n is your time. Now, I will go more detail about that. It's very important, this 1 over n. The reason I wrote 1 over n, not t, and I didn't also write r over n, but r times 1 over n. And just don't memorize formula. Don't try to say to yourself what n is 1,000 times so that you remember it, or write in your hand. And I was doing undergraduate or high school to cheat what they mean. Here, just remember it from an example. If n is 12, you're talking about monthly basis, then 1 over 12 is the time, because your money is being accumulated every month. So remember in the beginning I mentioned, is you have, if anything that is affiliated with the interest time, you have to convert it into year basis. So you don't say 1 month, but you say 1/12 of a year. So that's what n is. N is the number of months in 1 year, which is 12. Okay, then, so this is your time. This is your time. 1 over n will be your time, don't forget. And your interest is r, that remains fixed. So look at that. Principal plus interest. Do you follow me? And then I go ahead and do some algebraic manipulation. Very elementary algebraic manipulation. There are 2 terms here. Both of them, they have p in common. So I factor p, and look what happens when I do that. I get up p times this, so I end up with this formula. You follow me? Now, this, now when I factor it, you see p times 1 is this, p times this is this. Now this becomes your new what? Your new principal that you have in your account. Now, the interest is going to be paid upon this one. Exactly like the example I made. Exactly. Now look what happens. This is your principal that you start. I put arrow here. Then it's principal plus interest. Interest is what? Principal times rate times time. Principal times rate times time. Is that right? Now look what happens here when I do that one. This is principal times rate times time. This is your time. You see, again, you are in the form of, you have how many? You have two terms. Both of them, they have this in common. You see that? So this is your principal, this is principal times rate times time. So that becomes what? That becomes what you get on at the end of the second period, whatever it is that period, monthly or yearly basis or what have you. Okay, then, now look what happens this one. The rest of them is just a little bit algebraic manipulation. I factor this one out, you see that? So I'm left with these two. I end up with p times 1 plus r over n squared. So because a times a is a squared, is that right? So I simplified that one. It's kind of explanatory. So you can just, for yourself, you can pause and write the notes. It's very easy to see that. Now, by doing that, a nice looking formula is going to pop up. Fascinating. So I have that one. Another one I have written for you in case if you want to write the notes. Almost every textbook you can find them. But just to be consistent, let me also put that one up for you. The same as the previous one, no difference. It's just a little bit more explicit, more space I have put for that. So this one I just won't go over that, you can see the pattern. Now let me put it on in general and see what pattern we can see from that. So let me go and zoom this one for you. Okay, now here is just algebraic generalization. I'm generalizing exactly the same thing, but I put it in the chart. You see that? Now, before I start for that one, it's very important. Mathematics is a science of observation, collecting data, then putting the data, organizing data, putting the data into a chart or table as we did, and then look for pattern. Because when you put it in chart discipline, a pattern, if there is a pattern will form. So you will see pattern, then based on that you make conjecture, and then try to prove your conjecture that change into theorem. So this is, as a matter of fact, the mathematics should be taught, but unfortunately some teachers, they do not, and they teach us like, especially grade school and high school, as a recipe. They give us formula, plug this and this and this. I don't know if you are not learning mathematics really, you are learning like a cookbook style following recipe. And that's in fact the cause of the math anxiety, because mathematics is not taught correctly. Unfortunately, they do that to us, especially in grade school and high school. Okay, now this is very important to put it in chart, look for the pattern, and then make discoveries yourself. Now here, I started with the principal P, you see that? Then principal times rate times time. You see the time, I put it 1 over n. I didn't put n because depending on the n, if it is 12, is monthly. If it is 52, is weekly. So 1 over 52 is the duration of one period. So you go to periods of them. Okay, then now this is principal, this is what? This is the interest that you earn. Then principal plus interest is what? Is what you have in your account at the end of the year, or at the end of the period, whatever that one is. If it is monthly, at the end of the month. Now I put that one here in a simplified form, because P times this is P, then P times rate times time is what the interest, so this is same as this times this. You see that? This plus this, excuse me. Now, this becomes your what? This becomes your new principal. So here it is your new principal. The interest that you earn is what? Principal times rate times time. This is your principal, you see that? Principal times rate times time. 1 over n is time. And when you do algebraic manipulation and simplify, you end up with this formula. Do you follow me? And by doing that, you cover this chart, then you notice that when this one, look at that, when this one is 1, this one is 2. When this one is 2, this one is 3. You see that? The pattern is forming. So if this is m minus 1, this will be 1 more than that. That will be n. So here you are, a star is born. We found a formula. And that is the formula I showed here. And I said, okay, let's see where this formula come from. This one. So we are going to go more detail for that one. Okay, then let's now go to this one. Again, my apology, I don't have the proper equipment. I have to zoom in and out myself mechanically. Now, going back to that, this is the formula we just discovered. Is that right? And then this formula, this and this, I wrote it and I want to see what is the difference. This one is same, but this one is NT, this one is N. Now, what is the difference? You can see both of them in the textbook. Now, M represents the number of time that your money is being accumulated. Now, don't learn it what I just said. Don't learn it what you learned there. Excuse me, not don't learn it. Don't try to memorize what I just said, but try to see it through an example, because through an example you will not forget it. So here, M, for instance, if your money is being accumulated on monthly basis, which means at the end of each month, the bank is giving you interest, and that interest is added to the principal, you have a new principal, go to the second month. Is that right? Now, this represents the number of months that you are going through. For example, at the end of the 6 months, you want to close your account. Nothing wrong with that. So this is what you use, the formula, to find out how much, in fact, that's the way bank does. They use this formula to find out how much they have to pay you. So this 6 stands for, as we just went through, the one time, then second time, then third time, third month, at the end of third month, at the end of fourth, at the end of fifth, and at the end of the 6th month. That's what 6 stands for. Now, the difference between this and this formula is that, look at that, he has N and this one has N and T. So this is kind of more appealing, and also you work with it with respect to the time, with respect to the year, period for year. Now look what we did. Here, 12 is the number of months. Is that right? I'm making through example to learn it. 12 is the number of months, so the money is being compounded monthly basis. All right? Now, this was 6 months. Is that right? What is 6 months? 6 months is 12 divided by 2, which is 12 times 1/2. Isn't that right? Because you have to write it in anything affiliated with the interest, you have to convert it into year basis. So here the year, 6 months is what is half a year. So half of 12 is 6, you see that? So these two formulas are equivalent. They are not identical, but they're equivalent. They're saying same thing, but the advantage of this one is that this N and this are same, and also this goes per year. So it's half a year, 1/4 of a year, whole year, 2 years, so you're talking year, not the month anymore. Are you with me? Okay, then now let's go and see what we can come up with. Now that we have discovered the nice looking formula, this we call it now, in a sense of logic, we went inductive, which means we went from a specific to general. So from a specific example, we generalize the idea. Now we use the general form for any specific, any special cases, and that is called deductive reasoning in the language of logic. Okay, then now let's go through deductive and see what we can come up with. Now, since this is general, so why not select the easiest possible example and see what you can come up with. And the easiest possible example to make is to select your principal to be $1, to select your rate of interest to be 100%. And then when you do that, you see how fantastic something comes out of it. Curiosity. They say curiosity killed the cat, but in the case of human being, curiosity makes Einstein, does not kill you. All right, let me see now what we can come up with that idea. I have written for you if you like to, it's already in Zoom mode, you can see that. Now I have another form of it, I'm going to put it on. Now, we have succeeded to establish a general formula for compound interest. This formula can be applied to any specific case and that is what I already said is deductive reasoning. So the case that I selected to be the t, the time to be 1 year, and then the principal to be $1 and the rate of the interest to be 100%. I couldn't be easier than that. Now look what happens. The amount is 1 times 1 plus 1 over n. Do you follow me? That's the reason I selected 1 over n rather than r over, I selected r times 1 over n rather than r over n. That's the advantage, so that conceptually you can understand it better. Now, look what happens here. When n is 1, which means 1 year, so you look at that, 1 plus 1, you get 2. When n is 2, which means you are combining twice, then you get what? 2.25. When you do that, 1 plus half a square is 2.25. When n is 3, simple arithmetic, you can use calculator, 1 plus 1/3 cube, you end up with 2.37. When n is 12, you get 2.61, and so on and so forth. And when you come up here, you can change not the time into, I've changed it in fact to the year, to the days, and then to the hour. I went up to the, I did go to the second also. So it's about 365 days a year times 24 changes into hour, times 60 changes into minute. I didn't go to the second. So I end up with 2.71827. A nice looking number is forming out of it. And that number is very famous and has so many applications in mathematics and science. It's much, much more important than the so-called pi that you are very familiar with that. It's one of the most important number that we have discovered from very elementary grade school arithmetic, which is fascinating. Now, the letter E stands for this number in favor of Euler, which was who was a known famous mathematician. Now I have another this which is exactly the same thing, but a little bit kind of written more explicit. I thought I hang it up for you also. I hope that is focused because this is the other way around. Again, check it. Now, again, principal is 1, time is 1 year, rate of interest is 100%. So I go through this, exactly what I did. The only thing I put it a little bit in more organized because the other one was a little bit compact. And I hope that is visible to you. I will check it at the end to see if I can focus it, if it is out of focus. Okay then, now one thing that is important we notice is this one. Now, here, if you do remember, I put is already in focus form. Now we want to know where was it? Here. We want to know where this formula come from. You remember I gave you a textbook. They give you 1, 2, 3, 4, 5 kind of formulas that beginner student are a little confused. Basic algebra usually use this one, but college algebra we see all of this. Now we are going through this to see where this formula come from. Very fascinating formula for continuous compounding. Now here, one thing we have to know is about the number E. I already gone over through that, and must be 1 and 1. Remember that, 1 and 1. So this is 1 plus 1 over something. That can be 2 over 3. Excuse me, 2 over n. So whatever this one is 2 over n, this one also should be 2 over n. If it is 1 over n, this should be 1 over n. Do you follow me? So these two, you know, it says it, this just picture shows everything for you. Don't forget, this should be 1, this should be 1. Now look what I do here. We are familiar with this formula. We already know where they come from, huh? We just developed that one. I want 1, but this is r. I have to change it. But how do I change it? It's cosmetic changing. You put just makeup. So what is 3? 3 is same as 1 over 1/3. Is that right? What is 2? 1 over 1/2. 1 over 1/2. Is that right? So instead of 3, I write 1 over 1/3. So instead of r over n, I write 1 over n over r. This is the equivalent. Now when I do this one, look what happens here. This n is exactly, I want to make it like that one. So I make it like that. I write n over n. But this one was not n over r. Hey, what happened? I have to get rid of this r that was not there. Algebraic manipulation, very simple, okay? A to the m to the n is a to the m times n. You multiply the powers. So if you multiply n over r by r, you see that? R and r, they cancel each other, so you are left with mt. You see that? mt. Do you follow me? Now look what happens. We end up with this, with that formula that I just came. Where did I put it for the... I lost it. Doesn't matter now. Now here you see that I have 1 plus 1 over x, 1 over x, x and x. So 1 over this and this are same. So when they are same, n over r, so look what happens. This one, as n approaches infinity, this approaches to a e number. So you end up with e, this is e to the r to the t. Amount equal principal times e to the r to the t. And that is the for continuous. And this number, as n approaches infinity, in this case, is what? Is e, that we already saw it. And e, when the n approaches infinity, means what? Means we are compounding per year, 365. Then you change your mind, you change it, you compound it per minute, which is times 365 times 60. Then you say, okay, I want my money to be compounded per second. So you change it into 365 times 60 times 60 and so on and so forth. You can go forever for this one. Now, when the bank is advertising that they are paying interest on continuous basis, that's what the formula they are using, but the difference is so little. For example, if it is on daily basis, and the other bank says I'm giving you hourly basis, the difference if you have $100,000 in your account, maybe at 5 cents or something like that. So you're not going to change your bank from one bank to the other one for only 5 cents in ratio to $10,000 you had in your account. It's just a joke, huh? So the difference is very little, because the number keep going, become, e goes forever. It's an irrational number, but irrational numbers are also, there are different kind of irrational number. One of them is called transcendental number, and e is one of them. Okay, then, I think I have done that one, and let me okay, then my apology that my equipment are very primitive, but that really doesn't matter as long as I'm conveying the knowledge to you, and I hope that you have learned. And I have some other basic algebra stuff, calculus also in my channel. You're welcome to watch them until hopefully I settle down and put my feet on some solid ground and get a good position so that I could use the facilities of that institution. I would like to have a lot of videos on different subjects. All right, then I thank you very much for watching, and please stay safe and have a nice prosperous day. So long.